Back into our instrument machine, just again a brief explanation about the machine. We have two jaws here, fixed jaw and movable one. We are going to fix our sample here between those two jigs, and then software automatically apply the force, and we could see the stress-strain graph and the whole process from elastic to plastic, and then past the maximum necking and breaking. So I'm going to start with copper sample. Our original length is going to be between those two jigs. So first we need to install the sample properly. So I try to keep it equivalent from both sides, inside. I'm going to fix the jaw first, and then the top one, keep it straight. You're done, everything is fine, so just close the door. Oh, before that, let me measure the length. That on. So the length going to be right here. It is 109.89 mm for copper. Now, coming here, make the settings to run the test. It is copper for fall 2020. Next, copper sample 109.89. So make sure you calibrate the extensometers and the load cell. It's ready. Hit start. It's going to create our stress-strain graph here. As you can see, it's going to pass elastic, plastic, and going through maximum and necking and breaking. Now if we switch to our sample here, if we check from the side cross-section area, it is on max based on the graph, means we haven't entered to the necking. It is on plastic region because it is copper. It's going to have a very big, large plastic region. And now start to moving down. You can see from the top, necking start to apply. See, this is necking, and at the end breaking. So normally software need to stop that. As you can see, the software didn't realize the break, so it's continuing and apply the force. So we're going to stop it manually.
Test ended.
So we cannot rely on those values here because our stop point is here and it's continuous. It was continued. So the load won't be that and the extension won't be that. We need to figure it out from here by getting the strain and find the final extension. And the load also, we can get it based on tensile strength that we have. This is a strength MPa, and this is a strain, no unit for strain. This is elastic region. At some point plastic start, then necking and breaking happen here. As you can see, we have a very big plastic because we are talking about copper. Copper is a tensile material, so that's going to have a bigger plastic and permanent deformation. So before getting the results here, let me show you the sample. So the final length going to be this length here. I'm going to measure that again. So 131.25 going to be our final length. If you remember, the original length was 109.89. So the difference is around 22 mm. And if we just have a look to our sample, this is how breaking happened. Look at that, the area reduced here, and then at the end no more reduction, and the sample gave up and was broken. So this is our first sample, copper. Coming back to the graph, next asked us the final length. It was 131. And it adjusted that based on 131.24. Now I'm going to get this graph on desktop. I'm going to save that there. I'm going to print that as a PDF. It's going to be my print. So, copper sample. 20. Save on desktop. And this is the file that I'm going to give it to you, and you are going to derive the information that we need from the graph. You can use ruler and do the all measurement. So let me get another graph here too. This graph going to be from here to here. Even I can make it more precise from here to here. Yep. So I'm going to print this as well. So copper 20. Desktop. So this is more probably close, and you could get the results from this more precisely. Let me do something else also. So I'm gonna write down original and final length here. Original length was 109.89 and final length was 131. Fall 2020. Oh, this one. This PDF. 109.89, 131.24. And this one also. 109.89, 131.24. So I will share that with you guys later for the lab too. So this is our first sample. Let's start another sample.